Hi folks, welcome back to 9.2 Arithmetic Sequences. In this video, we're going to take a look at something called arithmetic series. Now, you'll often hear this word series, and what series stands for is that summation notation we learned about in 9.1. And so when we have an arithmetic sequence, if we add up all the terms, that is called an arithmetic series. Okay? So let's say that we have two different types of series. So one type is that you could have a finite series. And the other type is that you could have an infinite series. So what's the difference? If I take an arithmetic series and it's finite, what that means is I'm taking a few terms, let's say 20 plus 16.5 plus 13, all right? Those are the only three terms in the series. If I add them up, 20 plus 16.5 plus 13, I get a sum of 49.5, okay? In other words, that if you have a finite arithmetic series, you can always find the sum. All right? So if I give you 3 numbers or 10 numbers or 100 numbers, you could add them all up. Now, there is a nice formula that will help shortcut adding them, especially if I say add up 1,000 numbers or add up 2 million numbers. It's nice to have a formula. So what is the formula for an arithmetic series? Okay, that formula is S sub n. So the S stands for series, and the n is how many numbers you're adding up. You're going to take n, and you're going to multiply that by the first term in your series, plus the last term in your series, and then you're going to divide it by 2. So let's see if this works with the 3 terms that we have above. So how many terms am I adding up? Well, I'm adding up 3 terms. The first term is 20, plus the last term is 13, and I'm going to divide that by 2. So 3 times 20 plus 13 divided by 2 gives me 49.5. All right? So this formula will work if you have a finite arithmetic series. So let's go ahead and put a box around that formula because it's pretty important. All right. Well, what about if you have an arithmetic series that is infinite, meaning that it's 20 plus 16.5 plus 13 plus, and I keep adding forever and ever and ever and ever? Well, in this case, if I keep adding, the numbers that I add are going to get more and more and more negative. Which means that if I add these all up together, eventually I'll get negative infinity. Okay? Well, what happens if we have a sequence where I'm adding numbers and the numbers are getting bigger? So let's flip this. 13 plus 16.5 plus 20 plus, the numbers are getting bigger and bigger and bigger. Well, when I sit and I add up every single number here, I'm not going to get negative infinity. I'm going to get positive infinity. Okay? So this is going to be true for every arithmetic series that is infinite. That when you add all the numbers in an arithmetic series, it's going to get to negative infinity or positive infinity. And when you get to negative infinity or positive infinity, that means that this series, so arithmetic series, always diverge. Okay? So diverge is a new word for us. Diverge means that when you add them together, your sum will be negative infinity or positive infinity. Okay? So if I add them and I have a common difference that's a negative number, I will get negative infinity, which means it diverges. And if I add them together and I get positive infinity, that also diverges, okay? Now, sort of the opposite of diverge is a word called converge. I think we talked about that in one of the other videos, all right? So converge means that if you add up all the numbers and you get to one number, it's going to converge, all right? So that's just something that we will talk more about in 9.3, but I wanted to tie it into what we're learning in 9.2. So let's apply our formulas, all right? So example 3 says find the sum of all even integers from 2 all the way to 1,000. So let's list a few of these. 2 plus, what's the next even integer? 4 plus 6 plus, I'm going to keep adding, plus, what happens when I get towards the end? 996 plus 998 plus 1,000. So you can sit and type all these numbers into a calculator, but I bet you're going to forget a number. I know I would. Or you're going to type in a number wrong. I know I would make that mistake. So let's see how this S sub n formula can help us find our answer. So S sub n equals n times a plus 1, or a sub 1 plus a sub n, all over 2. So let's see what we know. I know that my a sub 1 is 2. That's my first number. I know that my last term is 1,000. But how many numbers, even numbers, are there between 2 and 1,000? Well, I know that from 1 to 1,000, there are 1,000 numbers. And of those 1,000, half of them are even and half of them are odd. So I know that there are 500 numbers. So my sum here is going to be adding the first 500 even numbers. And when I do this, I'm going to get 500 times 1002 over 2. I can divide that. I get 250. All right. So 250 times 1002 will give me a very large number, 250, 500. So if you sat and added up all the even integers from 2 to 1,000, that's the value that you would get. All right. Let's try another example. All right, this time using summation notation. So summation notation, all right, I know how to do this from our previous video. I could plug in 1, I could plug in 2, I could plug in 3, all the way until 5, and then add them all up together, all right? So let's use that strategy here. I get 2 times 1 plus 1 plus 2 times 2 plus 1 plus 2 times 3 plus 1 plus 2 times 4 plus 1 plus 2 times 5 plus 1. All right, what does that give me? 3 plus 5 plus 7 plus 9 plus 11. All right, so 3 plus 5 plus 7 plus 9 plus 11 gives me 35. And honestly, for a question like this is the process that I would use. I only have 5 terms. The equation is not that hard to plug it into, so just plug in your 5 terms, add them together, and be done. Okay? But let's take a look at how this compares to example 5. It looks so much the same, except, wow, I do not want to sit and add these all the way up to 500. So, in a case like this, it's really helpful if we can recognize what these formulas are. So let's look at this, 2n plus 1. Well, 2n plus 1, if I think about that, is a line with a slope of 2. Well, if it's a line and it's a slope of 2, this is the same thing as saying it's an arithmetic sequence. And if it's an arithmetic sequence and I want to add them all up together, I can use the formula I had from our previous page. So s sub n equals n times a sub 1 plus a sub n over 2. Okay, now I can only use this formula because I recognize that it's an arithmetic sequence. If it wasn't arithmetic, then I can't use this formula. Okay, so let's plug in our numbers. I want to add the first 500 terms. And so that means n is 500 over 2. And what is our a sub 1? Well, that's going to be 2 times 1 plus 1. That's my first term. Plus, my last term is 2 times 500 plus 1. Okay, so a sub 1 is this term. I just plug in 1. And a sub n is this term. I just plug in 500. And now, let's work this out. This is going to give me 500 times 3 plus 1001 over 2. I can cancel those to make a 250. And this is going to give me a sum of 251,000 if I add up the first 500 terms of this arithmetic sequence. Okay? So, as always, when you're learning a new formula or a new strategy, it's important to think about when you would use it and why you would use it. So again, I think we could use the formula for number 4, but it was easier to do it the way we already knew how. Whereas example 5, when I'm asking you to add to 500, that definitely is something easier done with the formula. Okay? All right, so that's it for 9.2. And in the 9.3 video series, we're going to talk about a different kind of sequence called geometric sequences. All right, I'll see you there.